All right, let's talk about this first, the official language. Do you know what this symbol is called? It's called the radical sign. And what you may or may not have known is that all the stuff, well, most of the stuff that you did in Algebra 1 required a square root. The reason it's called a square root is because in the radical sign, there's this implied little number hiding in here. That's called the index. So when you take, for example, this problem down here, which says the square root of 225, what do you think the index is? Yeah. There's a little 2 that's implied there. Kind of like when we write x plus 5, we really mean 1 x plus 5. When you write a square root like that, there's an implied 2 hiding in the radical sign, in the index. So of course I can change this number. So instead of taking the square root of 225, I can put a 3 there in the index, and then it makes it a cube root. So that's called the index. The sign itself is called the radical sign, and then what's written underneath it is called the radicand. Now what you're going to find out in this chapter is that these little radical signs are actually really annoying. In fact, if I invented the world, which I didn't, especially if I invented math, we wouldn't have radical signs at all. Because what you're going to find is that when you take something like the square root of 50, it's much easier to write that with exponents. Yes, 50 to the half power. It's going to make it a lot easier because how do you get rid of the square root? What would you normally do? You would square both sides, right? So you would square it, and then when you square, you learn that that undoes the square root sign. And the reason that makes sense is because if you have something like 50 to the 1/2 and you square it, what do you do with the exponents? Multiply them together, and then they become 1, so they kind of go away. You see that much better with these fractional exponents than you do with the radical sign. So we're going to eventually move away from this. But right now we're still in radical land, so we'll just go with it. Ian.
Is that one of the reasons fractions are cool?
Yes. One of the many reasons fractions are cool. Because they don't require you to use a calculator for the most part. So what's written underneath the radical sign is called the radicand. And I'll tell you now also, and I'll tell you later as well, if the problem starts out with the square root sign, then your answer should have a square root sign. If the problem starts out with a fractional exponent at the beginning of the problem, then your answer should have a fractional exponent. So a lot of students, they say, well, I always write my answer with a square root in it, or with a cube root in it, or I always write it with a fraction. Well, you actually have to look at how the problem starts. So if the problem has a fractional exponent in it, you're going to end up with a fractional exponent in your answer. We'll talk about some of those logistics more later. But let's go down to this problem over here. What if I want to take the square root of 225? How do I do that? Calculate. Well, you remember, like, for middle school, you make your little factor tree, or you make your factor ladder, or you do whatever funny thing you did when you were in middle school. And then you say, okay, 225, it's not a perfect square. Bummer, dude! So I had to make a factor tree. Well, what's 225 divisible by? 5, because you remember that, because it ends in a 5 or a 0. And then 5 times what? Yeah, it's kind of one of these funny things where you take 225 and you double it, and it becomes 450, and you take away the 0, and that's how you divide by 5. But they didn't teach you that here in America.
No, they should have.
So 45. It always works that way. And how about 45? Can that be divided any further, or is it prime? You are not telling the truth. 5 and 9. And then 9, 3 and 6? 3 and 3. Okay, then what's your next step here? Divide even more? No. All those factors are now prime. And since it's a square root in here, there's a little 2 hiding in the index. I'm looking for what? Pairs. You know, you like one twin drowns the other twin or whatever, and they get out of the castle.
Yeah.
Just don't worry about it. If you know what I'm talking about, it's cool. If you don't even worry about it. It's not worth your time. So Then a 3 goes out and a 5 goes out, and what do you do when you have more than one factor that goes out? Multiply them together, so you end up with 15. 3 times 5.
Wait.
That is the answer, yes sir. Nope, because this one's a perfect square, which means there are no factors left that I didn't circle. If there was another factor hiding here, David, like a 7 or something, then this would become 15 square root 7. But this is a perfect square, which you should have known, but that's okay. So now let's look at the problem on the right. What is different about this one just from the get-go?
It has
Let's use the vocabulary that we learned.
the radicand.
The radicand is different, and more importantly, the index is different. So, on the problem on the left, when the index is 2, we are looking for pairs of 2. When the index on the right is 3, we're not looking for pairs. We're looking for triplets. Ah, okay. So we're going to make our little factor tree thing, and really let's move away from the factor tree thing right now. This takes a lot of time, and I'm not a factor tree person. I am a do it in your head, write it out long way person. So what I mean is look at the stuff in there, 27r cubed, and let's just write out all the prime factors in one line so that we don't have to use 15 pages of paper for our assignment. Good plan, Mr. Vandewey. So, what are the factors of 27? It might be like 3 and 9, right? And then 9 is 3 and 3, so how many 3s do I have? 3 3s. So that's like 3 times 3 times 3. And then I have r cubed, so how many r's? Well, r cubed means you take r and you write it as a factor 3 times. Hey, since I'm looking for triplets, how convenient, I have a triplet of 3s. So then it's like one twin drowns the other 2 twins. Nope. One triplet drowns the other 2, whatever. Only one of them goes out.
Just like drown himself. They're all getting drowned.
I like to make fun of other people's stories. Oh, sorry, Mr. Lincoln. So, what do we have left? A 3 and an R. Yep. So it's not a big deal, right? I mean, like, what if we had a problem that was, you know, like a 5th root of 32? Would that be like, oh gosh, I'm gonna die? No, it's not. It's just, you just gotta write out what are all the factors of 32. So I start with 2's. When you're thinking about this mentally, 32, it's better to pick, rather than 4 and 8, pick prime numbers. So like start with 2. So that'd be 2 times 16, and 16 is 2 times 8, and 8 is 2 times 4, and 4 is 2 times 2. So 32 is 2 times 16, so I write the 2 down. And then I think about 16, which is 2 times 8, so I write another 2 down. And then I think about 8 being 2 times 4, so I write another 2 down. And then 4 is 2 times 2, so I have 2 2's left. Now, since I'm taking a 5th root, I'm looking for not pairs, not triplets, but quintuplets. Such a cool name. And then, so are there any quintuplets? Yeah, it's like 2. It's like I wrote this problem on purpose this way. It's called foresight. Yeah.
It's like you planned it out or something.
I did.
Whoa.
Okay, so are you ready for the, well,
Yeah.
let's stir the pot.
Let's just do the test. Yeah.
Stir the pot.
Paper bucket.
Stir. Stir everything together. Okay, so we got to talk a little bit about format. Because when you're working with radicals, there's different things that we want based on different things that we say. That's not confusing. If I just write the square root of a number, I'm asking you to find the positive answer to that. So remember, if you're solving an equation and it says like x squared equals 16, what's the answer? Don't just say 4, because that's a lie. 4. But it's positive and negative, so they're actually 2, right?
Yeah.
Okay, so that's in the context of solving an equation. But if I'm not in the context of solving a quadratic equation, I don't have to get two answers. So if I, got rid of,
Whoa.
I didn't think that was going to happen because I planned it differently. But let's do this.
Go back to the best way and twice.
Thank you, Quentin, for your proverb. Okay, it was very touching. Here I'm just asking for the square root of 16. So I don't need the negative answer, I just need the positive one. There's like an implied plus in the front. So if you want to write the plus in the front of it, you can. In order to ask for the negative answer, I have to put the negative sign in the front. So the square. Wow, it didn't like me at all. So we talk about the principal square root, we mean the positive one. If I have a negative sign in the front, I'm asking you to take the square root of 16, which is a positive 4, right? And then to make it negative, to multiply it by negative 1. It's okay, I'll figure it out. There you go. Oh, and it's supposed to say principal square root of it. Well, what if I wanted both of the answers? Well, then my job is to, in the front of the radical sign, put a plus and a minus. And then I mean both of them. Okay, now the plot thickens. Because what if I have, oh, I thought that was going to bring the red back. What if I have the cube root? Well, if you think about the cube root of a negative number, I have to get a negative answer, don't I? Because that's negative 5 times negative 5, which makes a positive, times negative 5 again, which is going to give me a negative. So you remember when you were working on square root problems and you ended up with something like the square root of negative 25? What's the answer to that? It's not 5.
It's not possible.
It's not negative 5.
It's nothing.
It's currently undoable. Yes. Currently. I want to emphasize that. I said currently undoable. Okay? So right now we don't have an answer to this because we can't come up with a number. 5 times 5 is positive 25. Negative 5 times negative 5 is positive 25. I can't come up with a number so that when I multiply it times itself, I get a negative 25. So right now that doesn't work. But if I put a cube root in there, the index just changed to a 3. Now I do have an answer that works. Mine doesn't happen to be a whole number, unless I did this, negative 125, in which case it would be negative 5. That would be an answer. Like this one. So when the index is odd, you can have a negative number inside the radicand. That's almost like a statement worth writing. When the index is odd, you can have a negative number inside the radicand. Radicand. Well, it's not like C-A-N-N-E-D. Radicand. I'm going with it. I'm from a different country, so that's my accent, we'll call it. See if I can erase this without bringing everything else to life. Yes. So if you have the cube root of a negative number, then we actually mean that the principal square cube root is negative. And I could do the same thing with an exponent that's even, like 4, and I could still get a negative answer if I put a negative sign in the front. Questions about that? There's all the other stuff. Blah, blah, blah. And what I like about your book is that it has this nice little summary thing.
You did it wrong. Did you just erase it?
It's cool. I know what I'm doing by now.
Oh.
Totally do it. Just gotta stay calm. Okay. So it has this nice little sum it up chart thing for you. There's a difference. You have to look for the index and see if it's even or odd. Now, there are different rules that apply based on whether the index is even or odd. So if the index is even, that's where you have to be careful because If the radicand is negative, then you don't have a real root. Remember, because you can't take the square root of negative 25. But if it's odd, you're okay. So use that little table thing to help you. And it's in your book. I'll tell you which page. It's on page 2. Okay, now let's start the fun. Do some examples. So for A, I have a square root sign, a radical, in the problem when I start. So that means if there is any kind of radical stuff, I'm going to have a radical in my answer. I was really going for red. Okay. So I have the square root of 25 x to the 4th. Notice that there's a plus or minus in the front. So how many answers am I going to come up with? 2. And I can rewrite the square root of 25 x to the 4th. 25 is 5 times 5, and x to the 4th means x times x times x times x. Since it's a square root, I'm looking for pairs. So I just circle my pairs. Whoa. Okay, go away. Whoa. Whoa. Apparently need to recalibrate. Circle your pairs. What does my answer become here? Plus or minus 5x squared. So, a couple little helpful hints that save you time and money. Danielle, you gotta be awake first. A couple little helpful hints. You know how to take the square root of a number, 25. When you're taking the square root of a variable that has an exponent, like this one is x to the 4th, my answer became x squared. When you take the square root of it, you are cutting the exponent in half. So what I mean is, what if I have the square root of x to the 6th and y to the 18th? Well, rather than writing out 6 x's and 18 y's and circling all the pairs, use your logic to figure out what my answer is going to be. Well, since I have x to the 6th, I'm going to have 6 x's, which is going to make how many pairs? 3. So that's half of 6. Oh, like half of a pair, and then you only get one, so it's like half when you start with. So what do you think the y to the 18th is going to become? Yeah. Now you're catching on. Then. And then it's 7 halves, but we'll get that. Right now, if you have something like no space. If you have something like the square root of y to the 7th, then how many pairs do you circle? 3, right? So that becomes y cubed, and then how many do you have left? 1, so that becomes the square root of y. Because that's the one that doesn't have a pair, it's lonely. So it stays in the radicand until it finds its twin.
Drowned, apparently.
Yes. Something about, I don't even know how to say the thing that's a castle or whatever. I wasn't there for the story, I just hear my students tell me about it.
No? Kind of morbid.
Maybe when we have show and tell, you guys can tell me this.
You guys gonna bring this to us? We gonna do show and tell?
What does that do?
Yeah.
Okay, how about B? It's prime. Well, my answer is going to be what? Positive or negative? Negative.
But we're done with that.
Okay, now, this is interesting. It's usually a bad sign when a teacher says that. We have y squared plus 2 to the 8th power. How many y squareds plus 2 are there? 8, and rather than write them all out, how many pairs do I get out of those 8? 4. So it would be like y squared plus 2 to the 8th, which is just like da-da-da times y squared plus 2, da-da-da-da. Ellipsis at the end to let you know it's forever, right? It keeps going, blah, 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 blah. Oh, that's a 2. And then in the end, you'll get negative y squared plus 2 to the 4th. Well, if you wish to expand that, you may, but I'm satisfied. Okay. It's just going to take me a long time to do that, so I'm happy. Let's see if the book is happy. I was just trying to show you here that there are going to be 4 of those pairs. Because well, we write it out 8 times, right? And then I'll have 4 pairs like that. So that's where the 4 comes from. It's up there. Yeah. Sorry. It's because I started writing square root. And then I was like, okay. Okay. On to C. What are we looking for now? Quintupli! I don't think it's quintupli.
I like that word.
I think it's quintuplets.
I like quintupli.
But I like that idea. Okay, hey, we already know what the 5th root of 32 is, don't you? That's an easy one to remember because it always shows up on a test. Hint, hint, wink, wink. It's 2. So I remember that if I want to write all this out, I'm going to take a lot of paper and it's going to be 2 times 2 times 2 times 2 times 2, and then x times x times x times, and y times, and you get really tired of doing that after a while. Okay, so in fact, I don't even need this 5th root thing. I'm just going to figure it out. And so are you because you're clever like me. So since it's a 5th root, I'm going to have 2. And what does that x to the 15th become? Well, how many quintuplets of x are there going to be? 3, because we'll have 3 sets of 5. In other words, I take the exponent and I divide 15 by 5. You get 3. And same thing for the y, right? 20 divided by 5 will give me 4. Yay! Yay, 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 yay. How did I get this 2? The 2 came from the 32. Because remember 32 is 2 times 2 times 2 times 2 times 2. Or 2 to the 5th power. So there's 1 quintuplet of 2, which gave me a 2. Alright, how about D? What's the square root of negative 9? The answer is, stay tuned. No, the answer is not real right now. Not real. Not a real number. What you're going to learn is that there are other things besides real numbers.
Imaginary numbers.
They're imaginary. They're not fake. They're just imaginary. I know. Now you're going to find out. Xander. Wouldn't the 2 be a 3? Well, the 2 has to do with the 32 that I'm taking a 5th root of. So if I take the 5th root of 32, and you factor 32 in prime factors, you're going to end up with 1, 2, 3, 4, 5 2's. So the 2 comes out. This 2 doesn't have anything to do with the x to the 15th. It has to do with the 32. Since there are 5 2's, I'll pull the 2 out. Because this makes 4, right? That makes 8. That makes 16. That makes 32. Does that make sense? All right. Ooh! You get to try. We'll call this one 1. We'll call this one 2.